Hi, this is a demo for Project 1 of Distributed Operating Systems submitted by Mugdha and Palak. Mugdha's UFID is 54219168 and Palak's UFID is 55510961. Now I'll start by downloading my code from the e-learning website. So this project is about mining bitcoins. There are two parts of this project, a server side and a client side. On the server side, the user tells how many zeros we want at the beginning of our bitcoin, and on the client side we actually mine the bitcoins. So the client code takes the IP address of a server as an input. So let us check what the IP address of a server is. The IP address is 192.168.40.1. I'll be running both the client and server codes on the same computer. So let me just extract my code here. Yes. And basically the main code is situated in the DOS Project1 folder. Along with that, we have a message flow diagram and a readme file and the results in the form of an Excel sheet. Now we go to the project and update our application.conf file. We give the IP address of the server in the remote actor part of the file, and in the local actor part we give the IP address of our client. In this case they are both same because I'm running from the same machine. But if you want to give run a client from a different machine, then its IP address goes here. Okay, I save it, and from the command prompt I navigate into the folder that contains my project and start an SBT console here. I'm using SBT to compile and run my project. The SBT version, Scala version and Akka version are specified in the readme file. Instructions on how to compile the project and run it are also given in the readme file, but I'll just go through them once again. So to compile the project, we write publish local in the SBT console and it starts compiling. And we have a success. Now to run the server side of the project, I say run main. My project package is called bitcoins and my main class is in the project1.scala, and the argument is the number of zeros in the beginning of our bitcoin, so I will give that as 6, and I start my server side. It says all bitcoins collected will be displayed on the server machine at the end of 5 minutes. On the client side, I run my code in the same way, and here as argument I give the IP address of the server, and my client side has started. Now it says that I have started a local listener on the client machine, and on the server machine you can see that the local listener has been added to the list. So now we have 2 local listeners. Each of these local listeners create 4 workers because I've set the number of workers equal to the number of cores in my laptop. So meanwhile the code runs for 5 minutes, let me just take you to the rest of the submission. In my message flow diagram, basically I have drawn the entire architecture of my code. We have a remote listener which runs on the server machine, and it's kind of the super boss which assigns work to all the workers. On every local machine, on every client machine, I have a local listener which takes work from the remote listener and distributes it among its workers. I have a timer actor which basically sleeps for 5 minutes and then after 5 minutes it wakes up and tells the remote listener to stop collecting bitcoins because time is up. The local workers are the actual workers who mine bitcoins. So, and we have like in this machine we have 4 local workers on every machine, and they'll be equal to the number of cores on the machine. So the readme file kind of takes you through the name of the team members, content of the project, what to do, how to modify the application.conf file, how to compile and run the project, the test system, which was basically a cluster of 3 Intel machines with i7 CPU and running at 2.8 gigahertz. The number of cores on each machine was 8 and its RAM was 16 GB. The machines were connected with a 10 Mbps broadband network. Okay, so I have also included a summary and analysis of the results. For testing, we ran the code for 2 minutes and the number of machines used was 3. So we varied the total number of basically we varied the load on each machine, and we varied the number of machines from 1, 2 and 3 and calculated and tabulated the results in an Excel file. So here it is, and the summary, and we've kind of summarized our findings over here. And in conclusion, we determined that our code will give better results for smaller workloads, but if the workload was too small, then message passing took a significant amount of time and it led to non-linearity. So we came up with 10, well, I think it's 1,000 operations per worker as the optimum workload for each worker. Okay, so the code is still running, and okay, now I'm just going to wait for the code to finish and show you the final result. Finally, after all the workers are done, the bitcoins collected will be displayed on the server machine, which is this machine, at the end of 5 minutes. So now all we can do is wait. I hope you like this, and thanks for your time. So sorry for the delay, so just hang around till the code stops, I guess. And the workers have returned, and it looks like we've got a total of 36 bitcoins with 6 zeros in the beginning. The final output shows this is the random string that we passed. It has Mugdha's UFID in the beginning, and all the bitcoins have at least 6 zeros. So we have taken the bitcoins with 6 or more zeros, and it turns out that we have found 36 such bitcoins. So that's it for the demo. Thank you. I hope you like it.